Yes, as I say, I normally start work at this time, and I'm going to show you the principle. It's very simple. So now any plastic tubes, any tubes. I do have some tubes, so I'll just put the end of this off. Bring the end. Now this, if this was the transfusor winding, there it is, it's quite empty. There's a certain number of turns on there, and there was a capacitor there. This would work the capacitor there towards the end of the winding and the two ends of the winding. And the two ends of the winding were connected to a pipe went through here, so it's supposed to be put one through like that. This is a pipe, like that. Okay, and this is an insulator, and in there there's a gas, which is air, not in this case, was the gas called air or deuterium. And the end of the wire is connected to electrodes which are inside the plastic, inside the tube. All it is to do is just have a rubber connection and a proper tube. And when you have another winding round on the outside, which is tuned to the frequencies of a capacitor there, or small capacitor, tuned to a particular frequency, and when it starts with the current flows and puts a high voltage through there, which ionises the gas in there. That ionised gas, which is transient, it's not contained, is this current through here, which at the same time induces a current in that gas. And because induced current repels the inducing current, then it will be compressed towards the centre. Now, I did do a proof in MathCAD that it was a central force, and I also measured it experimentally, which is more to the point. And you'll see it on the web page. I used a balance and show there was a central force. There's a lot of big argument about that when I said it goes all over the place. But if you do it properly, it's a central force. A little loop suspended in what helps coil, it's actually pulled in, and when you use it out underneath, since it was pushed up towards the centre. So it's actually a central force, very important. And that force is so powerful, it's transformer bursting pressure, and you can work it out from the forces involved. The current through there, which is the number of turns, time of current each turn, which is 0.45, 1.5 milliamp, 0.5 milliamp amps, 50 milliamps, and so if you have 3,000 turns, well, if you have 70,000 turns, you see it has 70,000 turns, so 70,000 times 0.45 is actually quite a lot of current. I can't remember what it was, it's about 3,600 amps, or 4,000 amps. And so the inside current, which is the same as the outside, is 4,000 amps. So you get this repulsion between the two currents, and the inner current is a gas, so it's the ions. The ions don't move very much, it's the electrons and the ions don't move very much, but there's an exhausting current, it's not direct current. And it repels it right into the centre, and each cycle it repels like that, and each cycle it gets so close together that the deuteriums get close enough together to exchange a meson and then eject a neutron and a neutrino, and therefore give off power, and that heat makes it expand across the magnetic field, induce current in the coil again, and that continues and makes it continue. Now, to make it safe, you have to have a break. Now, a break is a thick conductor around the outside with a short circuit. Now, short circuits are provided by a triac and a little transformer which picks up a 12 volt pickup from here, so that it's actually in the right phase, and so that it results in it being limited at a particular level. So, and that can be turned up and down if you have a variable transformer. So that's the sort of thing it does. And the other winding you have on it is the output winding, which is another 300 amp current, which goes to 12 volts, and that 300 amps, that 12 volts when you have enough turns, 50 turns I think, on this big one, and that will produce the 12 volts to drive a car. Only 12 volts is here, especially about it. And that's the principle. Very simple. And the other thing that needs to be done is a little circuit which is a relay which turns off the input exciter current at the appropriate time. So when the output from the transfusor circuit, the actual circuit, raises to 12 volts, that's as far as it needs to go. It's designed to work at 12 volts, so when the output current circuit reaches 12 volts, it's a 50 turn sense coil, and it also uses for internal power, so things like fans and things. That's 2 coils, that's 2 windings. That output then, oh shit, this is Scott, some rubbish. They come up with well, what should we say? It switches over at exactly 12 volts. That's done by a Zener diode, an ordinary diode. So when the voltage rises above 12 volts, the Zener diode conducts, and the relay is then transferred into a 12 volt DC relay, and that then turns off the exciter power, and it switches over, because it's on all the time once it's that valve's there, and it switches over to a light which comes on and shows the transfusor power has been produced, and that is a 3-watt bulb. I get it going 5 minutes, and it needs to stop because I turned it off because I'm afraid of it. I'm worried about the neutrons being produced. I later built a neutron detector which I have to reproduce again, which is also lost to the fire, which is acrylic sheet, tin which is thick about that size, with a little photodiode in it which picks up the pulses from the thing, essentially slightly curved to the end. Buy these things very cheaply. And that actually produces power. No, it doesn't produce, sorry, produces flashes, scintillations as a Kirchhoff counter. And that is put in a aluminium box which is light proof. That's all there is to it. And then that's picked up by a meter, or you have to have an amplifier, so a video amplifier or a high frequency amplifier, and then you put that through a diode into a meter, which indicates power, or you can go to a oscilloscope, which is slightly worse. It's very confusing because of the low rate. Because there's no power, there's nothing. But you get these bursts of data which come from galactic sources, from exploding stars. It's frightening. It also detects atom bombs and stuff like that. When the atom bomb's close, the thing glows and see it through the gaps, the tiny little gaps in the light in, let light in, let light out. Terribly frightening it was. And he got killed by atom bombs. So, life's dangerous. Well, who's bombed? It was actually the Russians who bombed us. So that's the transfusor. And that will produce power to drive a car, and the same thing, because the power depends on the load, up to a point, up to the limit of the conductors. The output conductor is a 300 amp conductor at 12 volts. So it's 312, 6. That's 3,600 watts, isn't it? It's 3.6 kilowatts, is it? 12 volts, 300. 3 times, that's 36. 2 knots. 3,600. 3,600 watts should come out. Now, I don't know how many horsepower that is. I think that's 500 watts to horsepower. So it's 3 kilowatts divided by 500 is it's 2 kilowatts would be 2 times 10, 15. It's about 6 or 7 horsepower, which is not very much, but it's going to drive a small car. Sort of thing a kid could have. A more powerful one have to have thicker conductors, or possibly more turns to make it more voltage, which is more difficult to make, and of course they'd be heavier. So if you wanted 400 amp wire. You have to have a thicker wire. Well, I think 400 amp wire would probably be okay. And probably the limit what you could bet. And probably have 50 turns, you have 100 turns. And that would be 24 volts. And therefore the would be 24 times 400. Which I do, calculate here, wonderful. To do me rusty brain. Oops, not very good. And this is what I do. This is my job. Physics. That's what physics is. And obviously that's it all depends on whether it works with the extra mechanism. It does work, you've tried it. The only proof of the pudding is in the eating, you've got to do it. So if I put 400 amps times 24 volts, that's 9,600 9 kilowatts divided by 500, and that gives you 19 horsepower, which is quite a very small car. 19 horsepower, I mean, you probably get 40 horsepower of a car, so you probably need a bit more amps, or a few more watts, so it gets more difficult. Obviously that would be the heaviest part of the car, and have to be in the middle of the car, and no matter where in these lightweight cars you have where the batteries are. And that's a bit. It could be made of some lighter material like aluminium coil. So resistive. So that's recover. It's flex, you see. So that's recover wire. So if you had instead of 50 turns, instead of well, let's say I had 50 turns, 100 turns. Right, 200 turns, that would be 24, 40, 50, 100 watts, 100 watts, 100 watts, 100 watts times 400 amps is 40, let's see, what am I doing here? Brain ache. 400 times 40 amps. 40 volts, 400 times say make it to 200 volts. 200 volts, it gives you that. It's actually 80,000 divided by 100 becomes actually. So okay, that crash the system, and it's it was 80,000 divided by 160 horsepower. That's quite reasonable. So that's the sort of thing, and that's I don't know because it's not as good as a diesel engine power to weight ratio. It's still quite good. Now, incidentally, I watch this program. I'm watching the SETI program, Social Extraterrestrial Intelligence. I had noise of a trumpet sound, and it sounded like a jackdaw or something, some sort of animal barking a noise, and by dance music, and what appeared to be French. Some stranded Frenchman. Madness. If it is coming from space, which is just possible, I suppose. Does look like it, and that is straightforward. But that's the idea, and the resonance core, which is much bigger than it's about that size, that's the heartbeat that keeps it going. That's where the extra compression comes from. Reaction occurs, and when you load it, the power goes up to match, but the extra current in the resonance course does not change because that's regulated. So that's the regulator, and so there's a clutch to regulate it, and it's a brake to regulate it, and the relay that switches over is obviously permanently switched over at that point. You can't switch it off at that point. And not have the ignition circuit. The ignition circuit, you unplug it. I demonstrated this because somebody from resting house. I unplugged it and it was still power. Well, they rejected it. I don't know. I probably thought I was tricking them. Obviously a trick, that wasn't. And the first one I did was an RF version, and I got the MP, and I was so impressed by it. I was terrified of it, but I got the MP in, and he saw it. And I switched off the power, completely switched it off. It was turning it off. And it was still there. The thing was giving me off 2,000 watts, and it caused problems with my dummy load, which is a resistor rather than a linear. That's a transmitting circuit. And that was impressive. It was just a tube of hydrogen and the resonance circuit, and the someone to start it up, and it was going. And it went for several minutes, and then I turned it off by switching the transmitter on again, connected it up, and running the power down, and that turned it out. But well, that's the only thing I could think of. So yeah, the local MP, sorry, he's Hammond, I think it was. No, local Tory, was it Tory MP? I can't remember. No, there will be no local Labour MP. Hammond, yes, and the other people saw it were people from the South Research Council came. They didn't say working well because they found some of my tubes which had used, and so they found helium in them. So I was able to convert hydrogen to helium. That is actually something. And I was doing quite well until they put me in this psychiatric. I don't know who put me in this, from my cousin. And well, they came to see me, but somebody started jeering terrible. It was absolutely awful. Never seen such a mess. And actually, it was terrible, man. He was always in competition with me for some reason, because I was cold. And I always got the job, and he didn't. I annoyed him, you know. We sort of the same jobs. So I'm sorry about that. He's all retired and forgotten about now. And well, I'm still going, so but he didn't understand. He tried to make cars and things, and it was copying me. Well, I don't know, it was copying me. And he's talking about results he got. Well, maybe he did, maybe he didn't. But he's trying to free me. Well, maybe he succeeded. I don't know. I don't care. But this is the thing here I'm building. Now there's another man, Kaspersky, is it? Kaspersky, I think it is. I can't remember his name, place. Terrio Kowalski, is it, somewhere in Georgia, who has something working, and I don't think he understands it from his description, but he has got a working machine and he's reducing kilowatts. This actually is capable of megawatts if you had a big enough car. So a massive thing like this. Well, that's what power stations are like. Bash, I'm just smashing about. Yeah. So that's my answer, and I'm not going any further than widening the coil and making sure the ends don't get close together so they can spark. You've got to short it, make sure it doesn't spark, and do some mounting, but and get the most of it fitted, and have the brake circuits will be shorted, but the actual electric circuits may not come here. Once I did that, it has to be put on a board of some sort. A wooden board and mounted properly, and the relays all mounted, and the process chassis even built. So chassis are rebuilt, so the relays are outside themselves. Before I had all mounted on the machine, which is not a terribly good idea. I couldn't think of the other way of doing it. Glued on and stuff. Terrible mess. So I'm trying to make it a bit more rational, make it a bit tidier. And that will be sent to Coventry, a place called Right Translations, which is the address. It's actually an address there. I don't know where it is, or what it is, but it's open 24 hours, so then it goes to my friend's place to be tested. And that's the process. And I think the man in Utrecht is building these brakes, which I think I've made more from fashioned with strap value, from somewhere in this area. And he's going to send it to me. Well, I'm going to send one to Right Translations, and so that can be fitted onto my other machine to make it safe. Okay. There is a brake on there, but it's not such a sturdy one. I think I could make one actually. It's a triac, a very hefty triac, with so actually the triac shorts out thing. And the triac is triggered by this AC transformer, which comes from the oscilloscope. So it's actually 12 volts, it has to be just 12 volts. Okay. I can't remember what details. It's actually quite complicated, and I can't work alone, so I need to work with the man in Utrecht and the man in Coventry. Apparently he's building a big shed to do his experiments, and he's going to use a water screen and a remote control to make sure he doesn't get irradiated. Something precaution I did not take, so I've probably got radiation sickness. Goodly. So I need vitamin C or vitamin B. Vitamin B I take anyway because I have anemia, but some anemia, but vitamin B and A and C are necessary for recovery from radiation sickness, or helps recover.